Now we have drawbacks of octet rule. So first one is your noble gas compound. So noble gas compound, in this one, some noble gases, for example xenon, forming a compound XeF2. Now here xenon is already, we have the 8 electron in the 8 electron in outer shell. So by octet rule we have told that anything having 8 electron is more stable and it cannot form further bond. So this cannot be explained by the octet rule. Second point is that in the octet rule, this cannot give the knowledge about the shape of the molecule. If I draw water like that, this is also okay, but actual structure is of water is this one. It is a band shape. So this about the shape of the molecule, whether it is a band shape, whether it is linear, whether it is tetrahedral, that is not explained by this rule. And also this rule does not explain the relative stability of molecules, means which molecule is more stable. Then these things cannot be explained by your octet rule. These are the drawbacks of octet rule. Next point, what you want to start, that is your lattice enthalpy. Lattice enthalpy. So if I have lattice enthalpy is the energy required to completely separate 1 mole of solid ionic compound into its gaseous constituent ions. Now if we have this one, NaCl, NaCl, Cl negative, Na positive, Cl negative, Na positive, Na positive, Cl negative, Na positive, Cl negative. It is three-dimensionally, it is arranged like that. Clear? Now if we have three-dimensional arrangement, means what? This is Cl negative, Na positive, so it is goes like that, like that. If we have 1 mole of this one, 1 mole of NaCl means 58.5 gram of NaCl is this one, or it is 6.02 10 to the power 23 molecules of NaCl. From that, if I dissociate to have Na positive plus Cl negative, if I dissociate that one to have constituent particles, 1 mole of these constituent particles, 1 mole of Na positive, 1 mole of Cl negative. If I can dissociate, this is what is called lattice enthalpy. Now it is like that a wall is already prepared. From that again you by hammer you break down to get small bricks, separate brick, then sand, all these things. So to separate them we required some energy. This energy is called lattice energy. There is some more terms are there. One is your bond length. Bond length. So it is the distance between the nucleus of two bonded atoms. It is the half of the distance if it is nucleus of first atom, this is nucleus of second atom. Half of the distance between Na and Nb. If it is 198 picometer, then half of 198 equal to 99 picometer. Remember the student, this can be calculated if this one is an homodiatomic molecule, for example H2Cl2Br2 like that. But if it is a heteroatomic molecule, then you required internuclear distance and radius of any one. Then you can calculate the radius of the other one. Another point, student, this is your bond length. Another one is your bond energy it is the energy required to break down 1 mole of bond. 1 mole means if it is 6.022 10 to the power 23 bonds are there, then what is the energy required to break down this bond to get H dot plus Cl dot? So whatever the energy required, this energy is called bond energy. Now Cl actually you have to 7 electron you have to show. If there is more electrons, it is shown like that. Then another one is bond angle. Bond angle is this one, the minimum angle that you can have, the bond angle. Bond angle is this. Bond angle is the angle between two same bond is called bond angle. It is 104.5 degree. 104.5 degree. You cannot take the higher one, always take the minimum one as bond angle. So these are some terms that I have discussed today, and rest of the things will continue in the next class.